Hello everyone. Again, welcome to this Air Academy's course on Linux and programming languages. Today we are going to begin our lecture with Linux basics. My name is Anand, and I will be your instructor for this course. I will be today, like I'm going to mainly talk about the Linux basics. Some of the history of Linux, how it evolved into where it is today, and why commercially it is very successful, and we will see why it is very successful commercially. And then we will also start working on the Linux with how it is structured. Mainly we will study about the file structures, file systems, and the various programs that are embedded in Linux. And then I will be taking you through how to interact with Linux. We will begin with some of the commands, the basic commands that we will review, and then I think we will cover as many commands as possible today, and then we'll leave it for the next lecture. So let's begin. So let's briefly talk about the history of Linux. The history of Linux is not complete without talking about the history of Unix itself. I think many of you are familiar with Unix, having worked on it in different times at different times so far. Unix is an operating system very similar to Windows or any other operating system that you may be familiar with. One other thing that comes to mind today is which is widely used is the iOS, which is the operating system that is in the Apple iPhones. Windows is very popular. That's the operating system supported by Microsoft. It's widely used in almost all the PCs today. Probably it has a market share of about 80% or so. Unix is mainly used in the scientific computation world, which includes VLSI design and many other areas. We will see why it is widely used in those computing world. The Unix itself was developed more than 40 years ago, in 1969 at the AT&T Bell Labs. The two pioneers, Ken Thompson and Dennis Ritchie, were the main people developing this operating system. And in fact, if you look at the timeline, actually it predates even the Windows operating system, which was probably into being in 70s. One thing to note about Unix is it is a command line interpreter. What that means is as you type the commands, that's how it understands what you are typing and what you are requesting, and then it services what you are requesting. It is developed for mini computers. As you know, the computing world itself evolved right in from 1930s when the big mainframes were invented by IBM. Then the IBM, then the mainframes actually shrunk into mini computers, and then in the 1970s the PC revolution started with the PCs becoming coming into the focus. For the mainframes themselves, the operating systems were proprietary, and people used to interact with the computers using punch cards and various other types of programming, not really developing any kind of personal programming interfaces. So it will be like more like a batch program. So everybody will be writing a program. They'll be submitting into a punch card machine, which turns the program into punch cards, and then one person collects all these punch cards, goes to the computer, he runs those punch cards, and then the computer will produce some results, again in the form of a punch card or some kind of a printout, and then that printout is distributed to everyone who wrote the program, and they can look at the results, and then they go and modify the program. The mini computers really started the revolution where the computers started interacting with people on a one-on-one basis. So this is again one of the key aspects, and this also prompted what is the time sharing, which means that every person gets a fixed time on the computer. I hope in your experience too, you must have taken these kind of computing courses where you actually sit in the terminal, do a fixed time of work, and then move on, and then somebody else will take your spot, and kind of a time sharing. You can also think of time sharing in a much more granular form that we will talk about in the later stages of the course. And again, as I mentioned, the Unix is the predecessor for Linux, and we will see like how Linux came into being, and what are the key aspects of Linux and why is it popular today. So Linux itself, Linux was created by Linus Torvalds in 1991. It is created as an open source. When Linus actually proposed Linux, he said that this is the lightweight operating system, and this needs to be an open system. And it is a variant of Unix in the sense that it uses predominantly the core basics of Unix, and then it adds some more. So one of the key aspects of Linux is this open source, and we will see like what is an open source and why is it important. So before we look at that, let's look at what exactly is Linux. So Linux is a fully networked 32-bit as well as a 64-bit Unix-like operating system. What this means is it uses Unix tools like sed, awk, and grep. We'll again talk about these things later on in the course. Just to remember these terms, sed, awk, and grep. We'll see what they are. It has built-in compilers for various programming languages: C, C++, Fortran, Smalltalk, and Ada. These are the two other languages that are also supported. These are expert system like languages. We won't be learning about these languages, but just remember that it has a support for multiple languages as well. And then it also supports networking tools like Telnet, FTP, Ping, Traceroute, etc. I hope you guys are already familiar with some of these terms. For example, Telnet allows users to communicate to computers which are remotely located. So they can actually use Telnet as a protocol to log into a computer which is situated maybe like across the globe, and then basically use it as a server to service whatever their programming needs. FTP is it's an acronym for file transfer protocol. Again, this is mainly used for transferring one file to another, one file from one location to another location. Again, we will talk about some more concepts on the FTP as to how we can use it and things like that. Ping is a just a remote system where you can actually see whether a particular machine is alive or dead using this ping program, and we will talk about all those things in a much later stage. Again, as I mentioned, Linux provides a way for multiple users to communicate or multiple users to use. So it is a multi-user, multitasking, and multi-processor system. Why is this important? Multi-user, because now it's not like your PC where you're actually sitting and you have your own system, your own window, you just communicate to it, and then basically like it serves you. And so, for example, if you are editing a Word document, that Word document is so personal that only you can do it. Unless you put it on the web or you use a mail program to send it to somebody, nobody else is will be able to see what you are trying to do. Whereas in a multi-user situation, actually you can do some things, and then your friend can come and add on top of it, things like that. So again, the multi-user is key aspect why it is preferred in this computing world, in the scientific computing world. Multitasking, again, you can simultaneously work on many tasks within the Linux operating system. This is another key aspect today. In personal computing world, like if you contrast it against the Windows operating system, Windows also allows you to actually have multiple programs open, but you still can only work on one program at a time. Here you can actually see multiple programs as one program runs. You can actually work on another one, things like that. It forms with multiple windows inside the same operating system. And multiprocessor, again, that is important because now you can actually add on processors to increase the throughput of a given program and work simultaneously with these multiple processors. Again, contrasting to Windows operating system, Windows provides maybe multiple CPUs in a machine, but it still is working on only one of the aspects of it. Whether it's multi CPU, multi core, it's still servicing only one user, one program. It has an X Windows GUI. Again, X Windows is different from your normal Microsoft Windows in the sense that now you can open up multiple terminals inside the same window and then work in each of these terminals differently. It also coexists with other operating system. One of the key things that you will notice that today's x86 world, actually now you can put two operating systems at the same time. For example, in your PCs, you can create a partition where you can have a Linux operating system on one side, one partition, and then the Windows operating system on the other side. It also runs on multiple platforms. Again, this is another key thing. As I mentioned, now the Linux works on x86. It also works on SPARC processors, HPs, DEC. You can name it. Like all these platforms can support Linux. And the important aspect that I mentioned in the previous slide was that Linux is an open source, and yes, so it includes the source code as part of the operating system. So even though we call it an open source, you have to think of this as providing this source code for majority of the programs, and we will see how this has evolved into even better and why people use it. So let's see why Linux is free. Linux is used today by a lot of companies. Number one is Linux is free, so you can view and edit the source code very easily. The source code comes shipped as part of the executable itself, as a part of the OS. Even though I call it like Linux is free, in reality it's really not free. There are commercial systems like Red Hat, Fedora, who actually produce Linux for commercial consumption. The thing is, even though Linus Torvalds' original vision was to have this Linux as a free operating system, it served a lot of purposes, but at the same time, support became an issue, and some of these companies took over the support, and so that they can provide the bug fixes and additional updates to certain features that the users are requesting in a more streamlined fashion. So that's the reason why there are commercially available Linux installations, and of course the commercial installations are attractive for the companies like ones who work on the design or VLSI design, for example, because they at least get a reliable installation of Linux rather than looking at the open source and see when some of the bugs may be fixed or something like that. and it is fully customizable. So again, people can write their own custom scripts and custom tools on top of Linux. And with, for example, if you have a real-time operating system or sorry, real-time processor, then you want to make it a real-time operating system, you can put your own customizations on top of the Linux operating system to make it real-time. One of the key features is the stability, which again comes from the open source, because once it is open source, it is tested and verified by large community of users, and they actually constantly test the new code, as well as they provide the bug fixes too. So it's basically about 30 years of testing has gone into this operating system, and hence we get a very reliable and a stable installation. Again, this is critical for critical applications. Even VLSI design, for example, is a critical application, and so we need these kind of highly stable environment. And it's also good for the shared environment as it offers today. Linux also has a better security structure. We noticed that actually in Windows we come across several Trojan attacks and virus attacks, but for the Linux side we seldom see any of these kind of attacks by the spurious program. The reason is the security infrastructure that is already built in as part of the Linux. Since all these the way that it works is very reliable and very consistent, it's very hard to break into these operating systems, and it's also highly portable. We can, if we have a new processor or a hardware platform, it's very easy to actually extend into that platform. And it's also written, actually it's written in C, so that actually makes it more portable across these multiple platforms. So now that we have explained why Linux is used by a lot of companies today, let's look at what are the main features of Linux, so that we can familiarize ourselves with Linux. So Linux has three most important parts. One is called the kernel, the other is the shell, and the third one is the file system. So let's begin from the bottom, which is the hardware. So again, the goal of the Linux is to actually for the users to communicate with the hardware. So on the bottom we have the hardware, on the top we have the users. So the users actually communicate with the hardware. So let's see how they do it. So the first layer that Unix, the Linux offers is the operating system itself, which is essentially has the process management, memory management, etc. They are the very low level programs which goes into the hardware resources, and they try to control the hardware resources. Okay. On top of these programs, we have the standard libraries which are used for opening, closing, read, write, fork, etc. These are the regular commands that are that support or that uses these process management and memory management and IO programs. They call these programs to do these things. and on top of that is the standard utility programs like shell editors, compilers, etc. And they actually call these other programs to facilitate how to do certain tasks. So as a user, you interact with these shell editors and the compilers. So as I mentioned earlier, the three main systems are the three main parts of Linux are the kernel, shell, and the file system. So you interact with what is known as the shell. And then the shell themselves have work with the kernel, which are the the various management functions, the process management, memory management, etc. And that in turn works with the hardware to satisfy your requests. So let's look at some more of the terminologies themselves. So when the users communicate with the shell editors, that aspect is known as the user interface. So as I mentioned, the various terminals that you open within the X Windows are all the user interfaces, and that part that forms the shell. And we will also see like what is the shell. The shell is actually driving. It's the program that is driving these terminals, so that you will be able to interact with the computer. Then the shell itself works with the standard library, and we just call it as the library interface. And then finally, the libraries are populated using these the management commands, process management, memory management, etc., which manages the hardware resources, and that's what is called the system call interface. That interface between the libraries and the operating system. On the other hand, we see that actually all these programs that really work on the process management, memory management, etc., they are called the kernel, and then anything above kernel is the user mode or the shells, and going in between is the file system, which we will see how the file system will be organized, etc. So let's look at the kernel in more details. So the kernel is the heart of the operating system. It's the lower level core of the system. That's the interface between the application and the hardware. So you can think of the kernel as essentially they are programs that calls various hardware resources, and they also make sure that your programs finally are getting executed in time on certain processors or on certain the hardware resources, and with all the resources intact, with the required resources. So the functions that it performs are managing the memory, managing the IO devices, and then one of the key things that we talked about was this shared time sharing between the processes. So again, it allocates time between the user and the process. It also does the inter-process communication, which becomes very key when we talk about whether we want to interrupt a process, whether a process communicates with another process, handing over things, and it also sets process priorities. So let's look at a brief example. For example, if you're writing a program, say like you're sorting a big array, so it knows how to fetch that array from a memory, and then you are actually interacting through the IO devices. So it also watches the IO devices as if there are any additional inputs that are coming in, and meanwhile another user can start a program to compile or he can start a program to actually go through a dictionary and sort and find a particular word. So it again time shares between these two processes, so that it knows like, okay, it works on this for some time, like a sorting program, while it goes and like searches the dictionary for some other time. And then meanwhile you may say that, okay, you know what, I forget this program, I want to kill this process, and then so I press the Control C. We'll see what are the commands in the later stage, but say you press the Control C and then now suddenly that becomes an interrupt, and it understands that interrupt and basically kill that process. And say like if you want a process to communicate to another one, essentially like, I mean, you have started a process now for reading the memory or writing into the memory, and then you want your answers to go into that process. Again, it basically understands which processes need to communicate between each other, and then it correspondingly does that. And when you're doing all these things, suddenly like the memory management process comes along and says that, you know what, freeze all the programs that you're running. Now I want to see like, I mean, how the various sectors are there. I want to compress some of the sectors, and then I'll free up. So that process gets a higher priority, and that's also set by the kernel. So you can think of the kernel as the main thing that drives all the things and making sure that everything works properly. So now let's look at the shell. What does that provide? The shell program is it's the topmost program or topmost interface between the user and the kernel, and it usually contains a command interpreter, and it also has its own programming capability. So what this means is a shell is something that you see in the terminal when it comes to a prompt. The prompt is represented as a dollar or a greater than sign. When it comes to that, it actually means that the command interpreter is active. Now whatever you type in is interpreted as a command, and once you press enter, that command gets executed. The command gets executed in the background. The shell understands that command, it takes that command, it executes the command, and then it spits out the results, and then again it goes back to that prompt and sits and waits for your command, the next command. So you can think of shell as your own personal slave. Is ready to do whatever it takes to satisfy the master. So you tell him one command, he just goes and runs the command, it gives you the output, whether it's an error or a real output, he produces the output, and then he sits back and waits for your next command. So he is really like a dumb waiter. Think of it, think of the shell that way. And shells are of multiple types. One particular shell is called the Bond shell. It's denoted as just sh, and it was the shell made by Stephen Bond, so he just called his own name, that is sh. And then the other one is the C shell. It is denoted as CSH. Actually, there's a typo here. Just note down that it's actually CSH. There is a modified C shell, which is also called TC shell, and then there is something called Con shell, which is denoted as ASH, and then there is the another shell called Born Again shell, which is also denoted as Bash or BASH. The Linus Torvalds first invented Linux operating system. He actually coded the Bash on top of the Linux. So the first shell that was coded on Linux was the Bash or the Born Again shell. So now that we looked at the second part of the operating system called the shell, now we move on to the next one, which is the file system. So once you understand the kernel, the shell, and the file system, then we can move on into the various commands. So let's look at this file system. one key concept of Linux is that Linux treats everything, whether it's a hardware resource or an I/O device, whatever it is, it treats them as files. So, for example, if you are using a keyboard to enter, the keyboard itself is a file. So you can say like read keyboard, which means that it opens a file called keyboard and it tries to read whatever you type in. So now my question is, how do you actually write it into a terminal? The terminal device is also a file. So if you write from your program into a file called terminal, that gets displayed into the terminal. Now the hardware resources are also like various files, so they get executed. We will see in the later sections as to how they are denoted. Usually they are denoted as /dev or devices. And one other key aspect of it is there is a fixed hierarchy for the file system, and that's how the operating system finds where everything is residing. For example, if you want to put a device, you will typically put it into a /dev, or if you have other files, you will be putting it into another location. Again, the top level of the directory or the top level directory is known as the root, and that is denoted as just the slash. So when I say /dev, that means that it is a hierarchy under that slash which contains some devices. And then there are several other things you will see like /etc, /bin, various things which denotes specific functions, and we will talk about that in a later stage. So now that we understood the three main things, we can start looking into some of the commands and how to navigate through the Linux operating system. So in order to get started, we need a couple of things. So when you start a device with Linux operating system, typically you go to the computer, you turn it on. Now what happens? You see like bunch of stuff going on your monitor, scrolling through the monitor, which basically initializes several devices, your file system, your disks, etc. and etc. Once they are all initialized, then the system boots up, and also it boots up the X Windows, and then finally it comes up with a screen which contains which asks you for login information. So the login information typically is you need to provide the username and the password, and the username is typically set by the system administrator. It is it's user specific. It's your own personal unique name. And in Linux, every keyword, every username, everything is case sensitive. So an uppercase Anand may be different from a lowercase Anand. So two people can have different usernames with just the case differences. And your password is also case sensitive, and password you can change at any time, even though you cannot change your username at any time. You need to go through the system administrator to change the username. We will see like how we can change the password in the later section, but password can be changed by the user at any time. So now that you have logged in into the system with the username and password, now what happens? So now the system actually comes up with a number of windows, maybe one window or several other windows. They are called the terms or X terms, which stands for just X terminal on top of the GUI. And inside each of the terminal, it also starts the shell that we talked about, and this could be one of the many shells that are supported that I talked about. And when you know that the shell is active because the shell comes up with a prompt, and as I mentioned, the prompt can be just a dollar sign, a percentage sign, or even just a greater than symbol. Once you have the prompt, now you can ask it to perform the tasks that you want to get out of it. So they are what are called commands. So these commands tell the operating system to perform a set of operations. So these operations, we will see what kind of operations can you ask the operating system to perform. The typical syntax of the command is as follows: the command followed by options followed by arguments. Again, command, options, and finally arguments. So how do we use these commands? Let's first talk about some basic commands, and then we will go more into how the more advanced commands and how we can string these commands together to perform various operations. So let's look at some of the basic commands. So these are all just shortcuts or control keys essentially. So how can we use the control key to perform various functions? So if you look at your keyboard, the control key is probably at the bottommost key and on your left hand side it just says CTRL. So we use that for doing certain operations. So in Linux, control S means it will pause the display. So once the display is paused, actually even if you type anything, nothing will show up on the terminal. The control Q on the other hand will restart the display, so that once you pause and you can restart using the control Q. The other nifty control sequences are control C that cancels an operation. So you type in a long command, suddenly you find that actually, you know what, I don't want to execute this command, let me cancel this one. You can do a control C on it, or say like you started a command using in the command interpreter, and it is just going and it is running, and you don't know, like I mean after 1 hour you come back and see that actually it's still running, and you want to just cancel that command because you know that it won't take more than an hour. So again you do the control C and immediately it aborts that command and then comes back to the prompt. So for cancelling an operation, you can do the control C. Control U cancels a line, again the same thing. Once you start typing a line and then you just wanted to abort midway, and then because you may have done a typo, then you basically do a control U and then just retype that. Control D is to signal the end of file, and control V is to treat any following characters as a normal character. For example, if you type control V and then control C, it doesn't take the control C, it just thinks that you just typed as a C and then it just types a C. Other nifty control keys are control A to go to the beginning of the line. So for example, you're typing a long command and suddenly you think that, oh man, I made a mistake in the command name and I want to change the command name. So you can just press control A and then immediately the cursor will go to the first character of that command, and then from there you can either retype it or you can use arrow keys to move left and right. And then the other nifty one is also control E, which takes you to the end of the line, which is also pretty useful when you want to come back after typing this particular or making a change in the beginning of the command. Now you want to go back to the end of the command and then start continuing to type the remainder of the command. Again, control E is a very good way to do that. So now that we understood the control key operations, let's look at how we can get help in Linux. So in Linux, you can get help in many ways. One of the ways that you can get help on a particular command is to use what is called man. The man is the short form for manual, so it is like opening up a manual and then looking at what a particular command does. So the way to use this option is just type man with some options, or the options are just optional, and then followed by the command. So the man options are this -m stands for the keyword path to the man pages, or -k the keyword list command for all the keyword matches. So you can say man -k, and then you can say anything that you want. Maybe you want to just say dir, and then it prints out all the keyword matches for that particular man command. So again, if you look at this one, this also the man also follows the same syntax that we talked about. That is the command followed by options followed by arguments. So here the command that you are interested in to get the man pages becomes the argument for the man command itself. So again, in Unix, this is one of the key features. Basically, you have the commands as arguments for various other commands. Now, another way to get help is to just type the command itself and then use a -help. Here, the -help is the option. There are no arguments, and then the command is just your regular command. And here you can use like -help and --help interchangeably. So now let's look at an example of how the man is used. So here I'll briefly talk about various pieces. First of all, the xterm. You see here is the terminal that popped up after opening the Linux. This is after you log in, and then finally it came to this particular prompt, particular terminal. And in the terminal you have all these various buttons. This is for minimizing, maximizing, and then actually removing this xterm itself. There is also, you can go to the border and actually click on it and drag and make the windows bigger or smaller for you to work with. Now let's look at here. Here it says the root is the name of the user here, and then this ACPER60 is the name of the machine that this person logged in. So here essentially, like, this root does not mean the file system root, but it is the person who is logging in. So this person's login name is root, which is essentially a super user, and then the machine itself is this KACPER60, and this is the directory. Typically this is the Linux is the directory, and then the $ denotes the shell. Here this is most likely a BASH or the bash shell. Now this person is now we are giving this command. So it's a man and then -m. So do you think this will work? Now you can see that actually it didn't work, because man as a command as an option, but does not have an argument. So it says this option requires an argument, which is the -n, and then this is the version of the man that is getting installed. I'll actually remove some of these annotations so that you can see it better. And now it also provides you with a usage how to use the man itself. So here it says man usage. All these are your options, including this, and then there is a compulsory thing which is the name, which is essentially the name of the command. And then it goes on to actually explain you as to what each of these options mean. For example, A is find all the matching entries. We already saw some of them. So the uppercase M that we saw, the path. To set the search path for the manual pages, the path. So if you give -m with a path, it uses that path to go and search for the man pages itself. And then we also saw like the -k, which is here it says basically like the same as the A command. So you know basically how to use that. The other options, some of the interesting ones like the print location of the man pages, -w. In fact, I typically use the man command with probably like even without any arguments, just man and then the command. That works most of the cases, unless you want to change some of these things. So this is one of the key things. So now you know how to get help within the system for every command. So this is what we will see in the next slide. So again, it's here it is described in more details. The -a lists all files and directories, even the hidden ones that are preceded by dot. So one key thing about Linux is some of these files you won't be able to see it when you do just a display command unless you provide this -a option. A stands for all, and then -l is the size, creation date, and the permissions. The L actually stands for long, so it provides a long option essentially. Like it gives you more details about various things. Then the -d actually lists the directory, and -c is it will not create a file if it is already present. We will see like how to use this. -f is typically means that to force, and -k is the block size. -r is another key option. This could be an uppercase R or a lowercase r. This stands for the recursive. And let's see like how we can use this one, because it is useful for copying, removing, things like that, to use this recursive nature. -c is the type, and then finally -v typically prints out the version. So if you want to know which version of a particular command is being used, you can just simply say the command -v, and then it should produce that version. For example, in the previous slide we saw that the Linux actually even by default it printed out the version as 1.501. Okay. So now we will go into various commands, and I will start with ls. ls stands for list, and this is mainly used to list the files in the current directory. So there is a concept of a directory. We saw the file structure with the root directory as the slash, and then there you can also have bunch of directories under that. So every directory contains number of files, and to list the number of files we use this command called ls. In fact, there is an analogous command even in the Windows world where you can display the number of or the name of all the files inside a directory. And ls also has many options. Again, as I mentioned, the -l, that's one of them, which is the long list, displays a lot more information. -t is list by modification date, which is very useful because it sorts by the modification date, and you can actually the -t option gives the files from the latest to the oldest modified. We can do a R to reverse that order. So again, you can combine like these, some of these, I mean actually all these options together. They're not, you don't need to use them exclusively. And uppercase S lists by size, H is lists file sizes in a human readable format, and then I told you the R reverses the order. A looks for all the hidden files. Again, the file names that start with dot are hidden, so if you just simply give an ls command, it won't show up unless you put an ls-a. And then uppercase F lists files of a particular directory. So one of the useful thing is here you can see that as I mentioned, the options can be combined. Can someone tell me what this command will return? ls-ltr. I think you are correct. This returns the long form of the files, long name. It sorts first by the modification date from the latest to the oldest, but then because you see an R, it reverses the order, so actually it displays the files from the oldest to the latest files displayed at the very end of the list. I think like you should be clear. I also urge you to actually type man-ls or man-ls to get the manual entry for the ls command itself. It should print you like all these options, and then it also tells you whether you need an argument or not. Again, I want to ask you that question too. Does ls need an argument? I think again you are correct. It does not need an argument because it just lists the files in this directory. And double L is again a short form which stands for probably the ls-l. So then these are what are known as aliases. We will also look at some of these things and how to set up the aliases in the coming section. But this will be a good introduction for ls command, and I want you to actually try it out and just play with these commands as we go along, and then see how they work and what you learn from them. So now let's look at actually using the ls command in a particular directory. So here again I don't have to remind you, it's xterm and in this terminal all these other things that I mentioned with the prompt, and then now you type the ls. So look at how it produces the files. This is just mentioned the ls, right? So it produces all these things. Now tell me how these are presented to you. They are just simply sorted on alphabetical order and then just presented to you in an alphabetical order format. So you can see that one, and you have to read it in various columns. This is column number 1, column number 2, 3, 4, 5, and 6. You can get the same thing with another option, also known as ls-x, that will also print in this format. So now we will talk about one more command. So let's go to that. It's called cd. cd stands for change directory. So anyone guess how to use this command? So cd is used to move between various directories. So if you want to move from one directory to another, you use this command called cd. So the commands that are most popular in Linux are cd the ls command. Does it need an argument? I mentioned that it probably does not have an argument. That is correct in most cases where you don't need to provide an argument, but you can also provide an argument which is you can type in ls and then space, and then you can say like a particular file name. Then if that file name is found in that particular directory, it just returns that file name. If it is not found, then it will tell you that this file not found. Now there is a concept called a wildcard, which we will learn in the subsequent sections. The wildcard is typically a character that kind of represents another variable or another name itself. So for example, you can say star or the asterisk symbol, which denotes any character, or a question mark will denote any character but only of one character length, whereas a star can denote character of any length or character stream of any length. So how can you use it? You can say like ls star.pl, then it will only give you the files that have pl in as their last two characters, or pl as the suffix, because you put like star.pl. If you put a star pl, then it will also return to you anything that has pl as the last two characters in that file, which is slightly a bigger set than the star.pl if it is available. And if you say like star txt, then it only gives you the txt files, which are in this case basically it is this copied file ex1 txt, ex2 txt, f1 txt, and maybe out.txt. So it is useful in ls command to actually filter for some files and the others. So this is again a very useful command, as I mentioned. And now let's look at the cd command. So the cd command essentially is, moves between the directories. We will briefly touch upon this. So cd directory name moves to a directory called the directory name. So the cd is the command name. There are no options, and the argument is the directory name. So it moves from wherever it is to this particular directory. So you don't need to provide where you are moving from, essentially, because it knows that okay, that's where you are anyway. So what does it mean by actually moving to a different directory? This means that any command that gets executed subsequently will start as from that directory as the reference. So for example, say you have a directory called /a, and you actually went to that directory initially, and then you are doing commands like ls. Then it produces the list of files within that directory called A. But now when you do the cd to /b and then put an ls command, now anytime the new command only like looks at that particular directory as its reference. So now it produces the list of files in directory B. Now there are characters which have special meaning. For example, the tilde, this denotes your home directory. So every user has a home directory where he or she has many other files, and we will talk about how to create the home directory and what is inside the home directory in a subsequent slide. So cd tilde moves the cursor to that particular home directory, that's your home directory, and so now whenever you execute any subsequent command, it always uses your home directory as your reference. Another one is this dot dot. The two dots denote go to the higher level directory in that particular hierarchy. So if you have a /a/b, and from that if you are issuing cd dot dot, it goes to /a. And then same way, like I mean the slash indicates the hierarchy separator for the various directories. So if you are doing cd dot dot / dot dot, then it moves 2 level up the hierarchy. Here we actually like the terms are slightly confusing. The hierarchy down, it's actually like I mean the cd dot dot moves it a level up essentially. So the way to think about it is like you have the slash as the root directory, and then say a, and then c, and then say a has a c underneath, and you are here the dot dot will move you up to a, and then the another dot dot will move you up to the slash. So if you want to go from C to B, there are two ways of doing it. One is cd/b, that will directly take you to the B, or you can say cd dot dot / dot dot /b. So that is another way to get to B. And cd minus actually typically moves using the wherever you come, it goes back to that place. For example, if you say from C cd dot dot / dot dot /b, so that now you are here, and then just say cd minus from B, it takes you immediately to C. So that is from the previous directory. So I think this should suffice for today's lecture. Let's continue from this point the next time. Thank you very much.